Hey everyone, I'm going to be doing selected answers from the DCP number 2 review, which means there will be some that I'm going to leave for you to do on your own. The first 4 questions ask you to write a slope-intercept form of the equation for each line. Remember, slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. Which means if we're given the slope and the y-intercept, all we're going to need to do is fill that information in. Y equals 3x plus 3, which means that I have a slope of 3 and a y-intercept of positive 3. If I were doing the second one, it says the slope is negative 2/5, so that's the m. Y is equal to negative 2/5 x, and the y-intercept is a positive 1, so plus 1. Which means that I have a slope of negative 2/5 and a y-intercept of positive 1. Great, all you have to do is write the equation given that information. Now the reason we start off so easy like that is because we can move and transition ourselves into a different kind of question here. It says, write the slope-intercept form of the equation of the line through the given point and with the given slope. Check your answer on Desmos test mode. Well, knowing that I am given a coordinate point and a slope, I'm going to need to use this equation, which is called point-slope form. But once I have it in point-slope form, I can just do a little bit of rearranging to get it back into y equals mx plus b form. So let's start with point-slope. Let's say I'm going to label everything because it might be helpful. Here's m, here's x1, and here's y1. So if I'm filling in y minus y1 equal to m times x minus x1, literally all I have to do is put all of those things where they belong. This would be y minus y1 equal to m times x minus x1. So that the slope is the m, the x1 is where the x1 goes, and the y1 is where the y1 goes. But now I need to change it so that it's in y equals mx plus b form. So I need to start with distribution since there's a number in front of a parentheses. That would give me negative 1x plus 1. And very simply, all I have to do is move that negative 1 over. It crosses the line so it changes the sign. This would now be y equal to negative 1x plus 2. And there's the slope-intercept form version of this equation where the slope is negative 1 and the y-intercept is a positive 2. Let's do that again for number 6. You'll have 7 and 8 to do on your own. So remember, we want to take the slope and a coordinate point. And since we have a point and a slope, we use point-slope form. To create my equation. Y minus y1 equal to m times x minus x1. But you see how both the negative 2 when I substitute it in and the negative 3 when I substitute it in have a negative negative next to it? Remember, a negative times a negative is a positive, or double negative. Really, we should just change those to plus signs because that's going to be easier to see. To rearrange it into slope-intercept form, all we have to do is distribute and then move. Combining our like terms together so that we have y equal to 2x plus 4. That's the slope-intercept version of the line that goes through the point negative 3 comma negative 2 and has a slope of 2. Now remember, it says to check your answer on Desmos test mode. So what I would do to check my answer on Desmos test mode is I would plug this coordinate point in and see if my answer that I got right here, which has the right slope, I can see the slope, make sure that that line actually goes through the coordinate negative 3 comma negative 2 on your screen. If it does go through that coordinate point, then you're good. If it doesn't, you might need to rewrite your equation because you probably did something a little bit wrong. Please check your work. We're trying to make sure that you have all the tools that you need to be good to go. We're going to skip now to numbers 13, 14, 15, and no, sorry, 9, 10, 11, and 12. It says to write the slope-intercept form of the equation of each line. Again, remember that slope-intercept form is y equals mx plus b, which really means We're just trying to solve all these equations for y. It's essentially 2 steps to solve an equation for y. We're first going to move the 12x to the other side. When it crosses the line, it changes the sign, and then we write everything down. Don't combine those because they are not like terms. Next thing I'm going to do is divide by the number in front of y. When I divide by the number in front of y, I'm going to get negative 2 over 5x. I would reduce that fraction if I could. And 35 divided by 5 is 7. There's the same equation. These two are equivalent, but they're written in different forms. You're going to have number 10 and 12 to do, so that means I'm going to do number 11. Again, if I'm trying to solve for y, or write it in slope-intercept form, we're going to move that 7x to the other side. Crosses the line, changes the sign. Now, I've done something wrong. What did I do wrong just now? Yeah, hopefully you notice that this is supposed to be negative 5y, and I only wrote down 5y. Make sure you use the correct sign for your coefficient of y, because that's the number that we are going to divide by. We would then do each of those division problems. Negative 7 divided by negative 5 gives you a decimal, so you'll change that back to the fraction 7/5. And negative 40 divided by negative 5 is a positive 8. Again, these two equations are the same, they're equivalent, they're just written in different forms. The first one is in standard form, the second one is in slope-intercept form. 13, 14, 15, and 16 ask you to write the slope-intercept form of the equation of a line that goes through given points. This is another one where we can visually check our answers on Desmos test mode, but here are the things we're going to need for this problem. Since we're given just 2 coordinate points, we need to find a slope. Because once we find a slope, we have a slope and a point, and we can rearrange it into slope-intercept form. So let's check out number 13. If we go ahead and label everything, this is going to be x1 and y1 because they're the first set of parentheses, and x2 and y2 because it's the second coordinate. So my slope is going to be y2 minus y1 over x2 minus x1. It'll be easier to do this in our head if we go ahead and get rid of those double negatives. So remember, negative times negative is a positive, so subtracting a negative is really like adding. This means that we'd get 1 over 10 as my slope. Cool. Now we're going to take that slope and the coordinate point, and we're going to plug that into point-slope form, because if we have a point and a slope, we can fill this equation in. Literally everything is already labeled. We've already labeled y1 negative 5 from earlier. We've already labeled our m as 1 over 10, and we've already labeled our x1 as negative 5. Again, we can change those double negatives to plus signs because it's way easier to deal with one sign at a time. Just like in the last section, we're going to distribute to get rid of the parentheses. This will be 1/10 x plus 5 over 10, which reduces to 1/2. Check a calculator if you don't know how I got that. And then we're just going to move the 5 over. Crosses the line, changes the sign, which means that I'm going to have y equal to 1/10 x minus 4.5, or, because you know I like those fractions, 9/2. Now, of course, we can check and make sure that this equation has the right slope, and if it goes through those 2 coordinate points. So what I would do on Desmos is I would plot those 2 points. So like type them in on Desmos, -5, -5, and 5, -4. They'll show up something like this on your coordinate plane. And if you type this red equation in, it will graph a line that hopefully goes through those 2 coordinate points. If it does, you've done this correctly. If it doesn't, something in your math has gone wrong. So please, please, please always check your work visually on Desmos to make sure that your math checks out, that we actually have a line that goes through these 2 coordinate points like we want. Since this one's a little more complicated, I actually want to leave you with 3 practice problems to do on your own. So 14, 15, and 16 are yours, but now you have a nice example on 13, and you have a way to check your work on Desmos test mode. Now, number 17 and 18 ask you again to write the slope-intercept form of the equation of the line as described. If we look at them both for a second here, we see that one of them says it needs to be parallel to a line and one of them needs to be perpendicular. Hopefully you remember that parallel lines have the same slope. So the slope we're going to use is the same, or 2. But hopefully you also remember that perpendicular lines don't have the same slope. They have opposite reciprocal slopes. So if this slope is -1/2, its opposite reciprocal is positive 2/1, or 2. Now, if you're given a point and a slope, all you need to do is use the skills we practiced earlier of y minus y1 equal to m times x minus x1. This equation is literally called point slope, and if you have a point and a slope, you want to use it. Okay, let's label all of our stuff so we're prepared. Here's going to be x1, y1, and then we have our parallel slope. Y minus y1 equal to m times x minus x1. I'm going to change that double negative to a positive. And then I'm going to get it in slope-intercept form, distribute, and then move. Crosses the line, changes the sign, it combines with its like term. This is going to be 2x minus 5. Now I could double check and make sure that this is actually parallel to the equation that we started with. Remember, parallel lines never cross, so they should be going the same exact direction. I can also make sure that my coordinate or my equation goes through that coordinate point that we wanted. If visually your equation is parallel to the line given and goes through that coordinate point, you have the right answer. I'm going to leave number 18 for you to do, but remember, perpendicular lines cross at a right angle. So when you're checking this one, your equation should cross at a right angle and it should go through that coordinate point, -1, -4. If it shows up like that visually, then you've written the correct slope-intercept form equation. Now, the next question on here, number 22. Oh, it really just jumps numbers, doesn't it? No, it didn't. We're over here. Wow. Sorry. Number 19 says to solve by graphing, and make sure that you are using the Texas Star version of Desmos test mode on this. Because if you use another version, you're going to be confused. This equation will not graph unless you've solved it for y. So let's go ahead and solve that for y together. If I have -7x plus 6y equal to -16, we're going to move the 7x to the other side. It becomes positive. And we're going to divide by 16. Let me make sure I write the equation down right. Divide by 6, divide by 6, divide by 6. We're going to have y equal to 76x minus 16/6. Now you might notice a couple things. If you just went ahead and graphed this equation and graphed this equation at the same time, something weird happens on your screen. Also, just look at the equations. What do you notice? Yeah, these equations are the same, which means we're going to have one line graphed. And then right on top of it, we're going to have another line graphed, which means they make one line. When you only have one line shown up, or when they're on top of each other, this solution is called infinitely many solutions. Very cool. Number 20 and 21 are yours, but remember, we're looking when we graph for the place where both of the lines meet, and that x comma y is going to be the solution to my system. So go ahead and graph both of these equations for number 20 and both of the equations for number 21. Hopefully you notice you're going to have to change this one, and find the solution to both of those systems. Number 22 asks us to solve a system by substitution. All right, substitution is the one where we're going to plug some stuff in. But if you notice, we already have one equation solved for y. That's great. So let's take that isolated expression and we're going to plug it into the other equation for y. Now I plug it in for y because it says y equals. This means that my equation used to say 4x minus 8y equal to 8, but now I'm going to be plugging in or substituting in that y value exactly there. 4x minus 8. Cool. We see a number in front of parentheses, we know we have to distribute. We'd have 4x minus 32x plus 64 equal to 8. I'm going to use the box method, but if you like to use inverse operations here, go ahead. There are two things with x's and two things without. I draw my arrows. Oop, cross the line, change the sign. I'm going to add across the top. 4x plus negative 32x is negative 28x. And negative 64 plus 8 is negative 56. Divide by negative 28, divide by negative 28. And you'd have x is equal to positive 2. And we do a happy dance because we are halfway. Remember, a solution is x comma y. So what I'm going to do is I'm going to take that original equation, the red one, but instead of x, I can now substitute this value for x right there. So this should say 4 times blank equal to negative 8, and that blank is 2. Well, 4 times 2 is 8, and 8 minus 8 is 0. So we know that our second part of this coordinate is 0. Our solution is 2 comma 0, x comma y. Great, we've done substitution. You guys are pretty good at this. We've also done elimination, and you guys are really good at elimination, so let's check this one out. The first thing we have to make sure that we have for elimination to work is that all of the variables are lined up. Do I have x's over x's, y's over y's, and constants over constants? Absolutely. These are both written in standard form. Do I also have some opposite terms? Yeah, I do. Yay, I don't have to do with a scalar multiple. Which means I add these equations together. I'm going to get the x's to cancel out, the y's to become 1y, and the constants to become negative 8. This means that y is equal to negative 8. And I can do a happy dance because I'm already halfway there. Remember, I divided by 1 technically to get this answer. It doesn't matter if you pick equation number 1 or equation number 2, but you're going to pick one of them, and you're going to plug that y value back into it. Okay, we're going to take this negative 8, we're going to plug it in for y. We plug it in for y because that is the value that we solve for. We solve for negative 8. Now you can use inverse operations or the box method here. I'm going to use inverse operations because I believe that it's a little bit faster to solve for the x. We have only one variable left. Add 16 to the other side. You have negative 2x equal to 20. Divide by negative 2, divide by negative 2. X is equal to negative 10. So our solution here is negative 10 comma negative 8 because solutions are always a coordinate pair written x comma y. We have an x value of negative 10 and we have a y value of negative 8. Cool. All right, the last couple things on this review ask about writing equations, systems of equations, and inequalities. So let's read number 23 together. It says, to get a score on, and this is true, by the way, this information is true. To get a score on DCP number 2 that is equivalent to a passing grade on the Algebra 1 STAR test, you need to get more than 9 questions correct. There will be multiple choice and free response questions. Write an inequality that represents the number of multiple choice questions, x, and free response questions, y, that you would need in order to get a pass on the DCP. Here is the other piece of information I have. I see more than 9 questions correct. So I need to remember the inequality table that you see below. Less than is your left hand, which means that that inequality symbol looks like this. Greater than is your right hand, which means the inequality symbol looks like that. Less than or equal to, again, because it says less than, looks like your left hand with an equal sign underneath it. And greater than or equal to looks like your right hand with an equal sign underneath it. We also know a bunch of information about this. We know that if we see the words smaller than, that means less than. If we see the words more than, it means greater than. If we see the phrase no more than, we have less than or equal to, or at most AM. For greater than or equal to, you might see no less than or at least. That's enough information to answer number 23. So remember, we saw the phrase more than 9 questions. More than is a greater than sign, which means if I add up the multiple choice questions and the free response questions, that needs to be more than 9 questions in order to get a similarly passing score on the Algebra 1 STAR test. More than is greater than. Last thing I want to fill out on this little chart here is the type of shading that you have for each line. Remember that the two that have the line underneath it are solid, and the two without the line underneath it are dashed. Then we just have to know if it's shaded above or below. But you can reason this one out. For something that's less than things are below. For things that are more than, things that are bigger are above. So follow suit for the same other two. There are a lot of topics that are going to be on this DCP, going all the way back to writing equations in point-slope form, all the way up to systems and inequalities. Make sure that you spend time studying each of these topics that you've seen on the review and that you understand the rest of the questions. I've left some for you to do throughout this review because I want you to practice as well. Good luck on the test.